Welcome back to this video series on nRF Connect for VS Code. In this video, we will learn how to debug an application. To debug an application, it's advantageous to have an application with a debugging-enabled build configuration. Most of the debugging features work without having this set, but to get the complete debugging experience, it is easy to enable. Just click on Edit Build Configuration and check the Enable Debug options before again clicking Build Configuration. Or you can do it manually by adding these two lines to your prj.config and do a pristine build. Then you will have access to all the debugging features, including thread, peripheral, and memory views. To start debugging, we simply click the Debug button here in the Actions view. This will build and flash your application. It will also start a debugging session by opening the Debug panel view, the Debug sidebar, and debugging controls. Within the debug sidebar, we now have multiple new views. Variables shows all the variables of the selected application and groups them into different categories. The variables that show up changes with which variables are active at your specific breakpoints. We haven't started debugging, so local variables are empty, but we can see that the CPU registers under registers here. When we run the debugger and hit a breakpoint, we will see the local variables that are active in that breakpoint here under locals. Watch lists the variables we have selected to watch. To watch a variable, we can either highlight it in our application, right click on it and select Add to Watch, or we can find it in the variables view and select Add to Watch. Call stack lists all the threads in our application and shows which threads are running. You can also expand to show the call stack for each of the threads. Breakpoints lists the breakpoints we have set in our application. To set a breakpoint, we click the little circle next to a line of code in our application, and it shows up here in the breakpoints view. If we want this breakpoint to be conditional, we can click on the little pencil to edit and write an expression or hit count that needs to be fulfilled for the breakpoint to execute. Peripherals show the peripherals on the SoC you're debugging on. In this case, the nRF 52833. You can also expand each peripheral to show the registers associated with its functionality and the content of those registers. We can also use this to write values to the different registers. For instance, we can set one of the GPIO pins that are high here to low to turn on the LED connected to that pin. Now that we are watching a variable and have set a breakpoint, let's try continuing our debugging. To do that, we click on the little blue play button up in the debugging toolbar here. Here we also find the common debugging tools like continue, step over, step into, step out, restart, and stop. Continue runs the application until we either hit a breakpoint or we pause it manually. Step over steps over the next function. Step into steps into the next function, and step out steps out of the current function. These are only active when the application is paused. Restart resets the board and starts the debugging session again, and stop just stops the debugging session. As we see, the breakpoint is immediately hit. The watch will show us the content of the variable. Here we see that the counter has counted 7 toggles, and the other local variable is for what LED was toggled 7 times, in this case LED 1. Let's have a look at some of the more advanced features of the debugger, specifically the thread and memory viewer. We find these by selecting the nRF Debug tab here in the panel view. On the left side we have all the threads listed and what state they're in. As we can see, the UART is running, the LED blinkers are suspended, and idle is ready. We can also see their priorities and stack usage. Clicking the entry brings us to the thread's declaration, and clicking the name brings us to the thread's definition. User options show us what kind of thread it is. We can see that the idle thread is what's called an essential thread. This means that the kernel expects this thread to be running at all times. To learn more about the different thread options you may encounter here, there's a link to the documentation in the video description. Then, to the right, we have the memory viewer. It shows us the content of the flash and RAM. If you hover over, you get more information on each address, and if you click the symbol name, it takes you to the definition of that symbol. This feature is helpful if you, for example, suspect a buffer overflow in an array, where the memory viewer can show you the content of the neighboring symbols that are likely to cause the issue. In the next video, we will talk about how to upgrade your SDK and toolchain to a newer version. Happy debugging!